Welcome back to the session of Boolean Algebra again. In this class, we will see the second theorem, which is De Morgan's theorem. De Morgan's theorem. Okay. So, according to this theorem, if there is an AND operation be under a complement, if there is an AND operation between the variables under a complement, you need to replace that with OR operation. Or with complement. You need to apply the complement for the variables as it is, but you need to replace AND with OR. Similarly, if you have OR operation under a complement, you need to replace that OR with AND operation, and you need to apply the complement for each and every variable. This is nothing but De Morgan's theorem. Okay, so let me give the laws below De Morgan's theorem, which is here I am considering only two variables. You can extend the De Morgan's theorem to any number of variables. It is logically true. Now I am considering the two variables A and B. Now I have A and B whole complement. A and B whole complement means under the complement I have AND operation between the two variables. Now, according to this De Morgan's theorem, I can replace AND with OR by applying the complement to all the variables. Now, I am replacing AND with OR, and I am applying complement to A so that it becomes A complement, and again I am applying complement to B, it becomes B complement. This is the first postulate under De Morgan's theorem. Let me write the second postulate. You can extend this De Morgan's theorem to any number of variables, but basically I'm considering only two variables here. Now, similar to this, I can do with OR operation also. I have performed OR operation between two variables, and it is under the complement. Now, according to De Morgan's theorem, this R is converted to AND so that it is changed as A complement and B complement. Okay. So R is replaced with one and I am applying the complement to both the variables. Okay. This is called as De Morgan's theorem. Okay. Now we will see one more theorem or law. We call this law, let me write this law here. We call this theorem as redundant theorem. Redundant theorem, or it is also called as consensus theorem. Redundant theorem or consensus theorem. Okay, what is this redundant theorem gives us? For example, if I have the Boolean equation or Boolean expression like this, f is equal to AB plus A bar C plus BC. For example, if I have a Boolean expression like this, now it looks like it cannot be minimized. It looks like this Boolean expression looks like it cannot be minimized because there is no chance of applying any postulate here. What I can do here is by modifying this equation a little bit, I can minimize this equation to further. Okay, let me show how to do it. It can be written as A B plus C. In order to apply redundant theorem or consensus theorem, the condition is you must have three variables. Here in this equation, how many variables we are having? Three variables. And second thing is all the three variables must repeated twice. Three variables must repeat twice. Here you are getting B, here you are getting B. Here you are getting A, and here you are getting A. And here C, here C. So each and every variable must appear twice, and you must have three variables. And the last thing is that in one term, one variable in one term, one variable must be either in only one variable, right? Either in complemented form, either in complemented or uncomplemented form. So what is the meaning for that? As you have three variables and all these three variables are repeated twice, so that you have six variables, right? Six variables. And in these six variables, you must have only one variable. This is the condition. In any one term, you must have one variable either in complemented or uncomplemented form. So this equation satisfies all the three conditions. Then you can apply consensus theorem here. Now, let me apply it. Let me take some space. Let me write that here. Now, it is AB plus A complement C. See the variable which is complemented. Here in all these three terms, A is complemented form. That's why see the term in which this A is missed. Here you have A present, here you have A present, and here the A is missed. Now I can write here this as BC and 1. Can I write like this? Because BC and 1 is same as BC, and it is equal to AB plus A complement C plus BC, and replace this 1 with the variable which is missed by using law of complements. So 1 can be replaced with A plus A complement. Is it right, Apna? Now just expand this term. You will get AB plus A complement C plus what is this term? First term ABC. What is the next term? A complement BC. Now, if you see the first and third terms, let me take separate color. If you see the first and third terms, you have AB as common. If you see the second and fourth terms, you have A complement C as common. Now, in that case, what I can write from the first and third term from this is AB I am taking common, so that you will get 1 plus C. Similarly, from the second and fourth terms, I can take A complement C as common, so that I will get 1 plus B. We all know from the postulates of Boolean algebra, 1 plus C is nothing but 1, 1 plus B is nothing but 1. When you are making AND operation with 1, you will get the same variables as it is. Hence, it can be written as AB plus A complement C. Okay. So, what I can write is AB plus A complement C plus BC is same as AB plus A complement C. This is called as redundant theorem or consensus theorem. The meaning of redundant is not necessary. Redundant is the meaning of redundant is not necessary. So in all these three terms, if you try to minimize, you will get this term removed. So this term is called as redundant term. What is this term is called as redundant term. Okay. You can apply the same thing with one more equation. You can apply the same concept with one more equation. Here I am using these three conditions to write an equation, right? You must have three variables. So I will use the variables x, y, and z. Okay. So I am writing a switching function in terms of x, y, and z. Let me do it. So I am writing a switching function in terms of x, y, and z. So first thing is satisfied. Next thing is each variable must appear twice. And the third thing is in one of the term, one variable must be in uncomplemented form. Now I will use this condition, right? So how can I write this is x complement y complement plus y z complement plus x complement z complement. Okay. So here if you see this switching function, you can understand that It has all the three variables x, y, and z. It has all the three variables x, y, and z. And each variable is repeated twice. X is repeated twice, Y is repeated twice, Z is repeated twice. And one variable in this term, one variable is in uncomplemented form. Here Y is in uncomplemented form. Then you can apply this redundant theorem to this switching function to reduce it. Now, how can I do it? See the variable which is in uncomplemented form, and this variable is missed in the third term again. Now form like this or replace 1. So x complement y complement plus y z complement plus x complement z complement into 1. Okay, or and the 1. Now 1 can be replaced with the y plus y complement. You can replace 1 with the x plus x complement, y plus y complement, z plus z complement. But in order to minimize it, I need to replace 1 with y plus y complement. Now expand the last term. You will get the first term as it is x complement y complement. Second term as it is y z complement. Third term is x complement. Sorry, let me write z complement here. X complement z complement y. And the fourth term is x complement y. Let me write this x complement y complement and z complement. Now if you see the first and the fourth terms, let me show you with separate color. If you see the first and fourth terms, you have x complement, y complement as common. And if you see the second and third terms, you have y, z complement as common. Now, from the first and fourth terms, by taking x complement, y complement as common, I can obtain 1 plus z complement. Similarly, from the second and third terms, by taking y and z complement as common, you will get 1 plus x complement. We know that from the postulates of Boolean algebra, it is equal to 1 and it is equal to 1, so that I can have x complement y complement plus y into z complement. This is according to redundant theorem or consensus theorem. So I can write x complement y complement plus y z complement plus x complement z complement as x complement y complement plus y into z complement. And this term is called as redundant term. Redundant term. So the meaning of redundant is it is not so necessary. That's why I can remove this and write directly. Okay. This is called as redundant theorem. In the next class, we will see how to minimize the switching functions using Boolean algebra. I suggest all of you to go through all the videos starting from Boolean algebra basics so that you can understand how to minimize them easily. Okay. Thank you very much.